This video is on percent composition by mass of an element in a compound and hydrates. In your notes, it's page 3 of your notes, and it's questions 19 through 22. So you can fill in your notes as you watch this. Pretty simple process, actually. So if we look at a compound like water, okay, you may say that the percent of hydrogen in water is 66%. In other words, you might say the percent of hydrogen is 2 out of 3. And you'd be right in terms of number of atoms. But usually we don't care about the percent of the atoms in there. We care about the percent by mass. Okay, so if we want to know the percent of an element in a compound, we're doing it in terms of the mass off the periodic table, so not in terms of the number of atoms. So to do that, to the percent of a certain element, we take the mass of that individual element, which could be either hydrogen's or oxygen's mass, divided by the total mass of the compound. So if we were doing water, for example, if I want to do the percent of hydrogen in water. So if I drink a cup of water, what percent of that mass is hydrogen? What percent is oxygen? Well, I would take hydrogen's mass, which is 1 gram per mole, and there's 2 of them, so that'd be 2 grams. There's 2 grams of hydrogen out of a total of, that's 2, that's 16, out of a total of 18 grams of water. So when you're drinking water, 2 grams out of 18 are hydrogen. Even though there's more atoms of hydrogen, they don't weigh very much. They have a small amount of mass, small number of protons, actually usually just 1 proton. So if I do that, that's about 11.1% hydrogen. So in terms of mass, water is about 11% hydrogen. That means the other 89% of the mass of water is oxygen. So really a pretty simple process to do. Number 19 in your notes. I want to know the percent of each element in barium sulfate. I could just ask you the percent of maybe just barium or just oxygen, but if I want to know the percent of each element, first thing I need to do is add up the total mass of the compound off the periodic table. So a mole of barium is 137 grams, sulfur is 32, oxygen is 16 times 4 is 64. So 64, 32, and 137. That is a total of, cheating here, 237, I believe. Sorry, 233. So if I want to know, say, the percent of barium in that compound, or percent of the mass, again, not percent of the atoms, percent of the mass, I would take barium's mass, which is 137 grams of barium, divided by the total 233 grams of the entire compound. So it looks like over half. So that's about 58. Again, that would come out as a decimal. That would come out as 0.588. So multiply by 100 or move the decimal over twice. 58.8% of that compound is barium. If I was doing the percent of sulfur, I would take 32 grams, sulfur's mass, divided by the 233. The percent of sulfur is 13.7%. If I want to get oxygen, I could do the same thing, take oxygen's mass divided by 233, or add those together and subtract from 100. All the percentages need to add up to 100, obviously. So let's find the percent in a normal compound. Number 20 in your notes is the hydrate. Okay, and we'll talk about hydrates. We'll do a lab with hydrates here in the next few days or maybe next week. And a lot of the compounds that we have are hydrated. Okay, they are compounds that have water attached to them. Doesn't mean they're wet. Doesn't mean they're dissolved in water. It means that they actually have some water molecules attached to them. A lot of times it makes them more stable, makes their shelf life longer. So let's say we have MgSO4, magnesium sulfate. You'll see a dot. This does not mean times. This is called heptahydrate. So magnesium sulfate heptahydrate. You could have copper chloride dihydrate. So you say the name. Heptahydrate means 7 waters. Dihydrate means 2 waters. So if you heat these compounds, it drives the water off and you end up with an anhydride or an anhydrous material. meaning the water has been removed. So our lab we do will be removing the water and figuring out a formula based on that. A lot of times what I'll ask you is what is the percent of water in this compound? Percent of water that's in this compound. So when we do that, do the same thing. We're going to add up these. So this is 24 grams. That's 32. 64 because there's 16 times 4 oxygens. 4 of the water is over here. You have 7 water molecules times water's mass. Well, water is 2 for hydrogen plus 16 for oxygen is 18. If we take 7 times 18, that is 126. If I want to know the percent of water in the compound, I need to take water's mass, 126, divided by the total. And the total includes the water and everything else. Okay, so our percent of water in this would be, there's 126 grams of water out of a total, 126 plus 64 plus 32 plus 24, out of a total of 246. Again, times 100. I'm writing downhill, sorry. So when you do that, you get 0.512, which would be 51.2%. So when I buy this compound, 50%, 51.2% of what I'm buying is water. You can do number 21 and 22 on page 3 of your notes.